And we will do dissection in physiological solution.
Physiological solution.
Physiological solution.
Okay, we have a cold spider.
Yeah, here is the spider.
And chilled for about 5 minutes. Okay.
Yeah. Here is the physiological solution of FSTA type, according to Lockwood, but we will send you the citation. It's important that it should be in the fridge to prevent tissues get more rot or something like that. Yeah.
Cold physiological
cold
solution.
Physiological solution. This can be stored in the fridge for several months.
Okay.
You don't need to autoclave it. And so now let's start with dissection.
What's this little piece of paper?
Just to put the spider.
Just a piece of paper, okay.
Yes, these are actually the best because, or I like them because it's possible to put the pin inside. You will see. So, if the spider is big like this, we can simply cut the petiolus by tweezers. If it is smaller specimen, you better cut the petiolus under the stereo microscope. You know, but in this size, I think we are okay. Just you can just cut the petiolus.
There's those little scissors that I covet.
Yeah. I will give you these scissors. Where is the rest of the spider?
We just lost the,
we just lost the sample.
spider, but that's okay.
Yeah. This now goes to Eva for her genome size measurement. It's also essential.
Awesome.
You will use all.
Yeah, and now put it into the dorsal part, like this. And I will gonna place one pin close to the spinning, close to the spinnerets, but not exactly into the spinnerets, somewhere behind, because if you put it exactly into the spinnerets, you will make a hole in the gut, and you don't want. So in this size, I usually hold it by one finger, and it is this, and that's the moment why I like this, because then you can go through, and you can just put it like this into the dissection
Nice.
tube. So now it's
That was fairly professional right there.
yeah, and now will be the most professional part, which will include the diagram. So this is now what we have because I do this I did this several times for students. So here are the spinnerets, here is the pin, here is the hole under the petiolus. So first cut will go this way. This is very important because gonads are here, but if you don't do this cut, when you will open it, everything will go up and there will be a lot of mess and you will have no chance to do the gonad. So this is the step one, this cut. Then you can put additive tin here,
Okay.
just to fix it, and then you can do other cuts this way. In idle case, this way and this way to remove spinners. Again, those cuts should be very long to go even behind the spinnerets, because when you will open it, you need to open it like a book to put the skin from one side and to put the skin on the other side and just open it.
Okay.
If there are some connections, there will come the tension and the whole abdomen will go out, and that's sometimes the way how to get gonads out very fast, but it's not exactly the way. I don't to už se nepamatuju.
How was the genus? What's the genus of this spider? This one?
Anachimus.
Anachimus.
A-N-A. First forward cut happening here.
Yeah. fixate it with tin in this bigger hole.
What's
Wait.
the family of the genus? Of the family?
Zoropsidae.
Zoropsid. Okay.
In the epigastrial furrow area. And now I'm going,
Posterior cuts.
yeah. Okay, you can see that I'm, yeah, so okay, so I'm just gonna open it and fix it with other nails. So one side. And the second side. So this is now remove the
So you're just pushing some of the fluid down
yeah,
onto the
yeah, exactly.
onto the specimen, kind of cleaning it off.
Actually, I think that I always gonads is the only gland which has ductus in this way.
Okay.
All other spinning glands has ductus in way to spinnerets.
Okay.
Yeah. Sometimes gonads.
So the gonad ducts are moving
yeah,
forward,
yes,
anterior. Okay.
Yeah. Sometimes gonad, or often gonads look like this zigzag structure, especially in megalomorphs. It's pretty easy because there are very huge gonads and they look like this zigzag. If the spider is old, then the sperm duct is bigger, full of sperms, and the gonads are smaller, which might be challenging to find them. But in subadults, it's usually okay, or in fresh adults. This depends on every species, every individual is,
Okay.
or every family is different in this way. For example, philistatids, when they are adult, they are already too late. It's already too late. The gonads are nearly degraded. So, but in those, let's say, leucocytes and related groups, it usually works in 2 weeks. I will do my best to. Yeah, now you can see it. Gonads are, the tracheas are all around the gonad that you need to know how it looks inside of the megalomorph.
Megalomorph gonad.
Are the legs. Here are your nails. In bigger megalomorphs you can put more nails. in Theraphocytes, for example. And here it is like this.
Okay.
Really like this. For example, in Theraphocytes, 200 preparations, no problem. You usually discard the gonad after the half of the day because you are not able to proceed it. We were doing Theraphocytes in the most clean water as is possible. this step is very sensitive for any contaminations, you know. Because I want to make my paranoia. I always put a small amount of the hypotonic solution and clean the dish with it to,
Okay.
to prevent contaminations
Okay.
with water. You know.
That's the
The-
hypotonic solution.
Hypotonic solution. They are identical, but just I just run off this one, so I take this all down. This is really the most, let's say, most sensitive step for contaminations or for whatever. We will always clean the bottle with extra care.
Okay.
Yeah, for hypotonic, and never use it for any other stuff than for hypotonic solution.
Okay.
Hypotonic glass is the holy glass. I remember there was a Martin. This depends on hypotonization is the individual or for each taxon should be optimized.
Okay.
For megalomorphs, where is a lot of chromosomes, we use 40 minutes and more. Yeah. This is where I expect that there will be something between 20 and 40 chromosomes in intelligence, so I think 20-25 minutes is kind of...
Can you describe what's happening during this?
During hypotonization, the water is going under the following the gradients and going into the cells. So the cells are absorb the water. They are bigger and bigger and bigger, and that's why the chromosomes are not overlapping each other, because the chromosomes are also the nuclei.
Are the cells going to burst, or that's kind of dependent upon the time?
That depends on the time.
Okay.
The ideal is that they just grow a little bit, but
Okay.
they stay intact. If the hypotonization time is too long, you have higher amount of incomplete plates because cells explode.
Okay.
And there are incomplete plates of chromosomes.
Okay.
Send you the catalog numbers, or I will keep some of them here.
Okay.
We use ethanol and acetic acid. The most classical form is methanol and acetic acid, but they work same.
Okay.
Just ethanol is less toxic, so it's easy to work with it. But the classical way in human cytogenetics is we're using methanol and acetic acid, 3 pieces of methanol and 1 piece of acetic acid.
Okay.
I mix it here in this. Always prepare fixativum fresh, because carboxyl acids and alcohols create esters, and you don't want to react and make esters, and you don't want to make esters. You need to have the combination of both fluids. So let's say after 2 hours or something like that, prepare the fresh fixative.
Okay.
Never store it overnight or something like
Okay.
that. Always fresh. So I just prepare the fresh one. I will take the...
This is at room temperature?
Yeah, room temperature. All steps are in the room temperature, except of storage of physiological solution.
Okay.
So I will take these embryo dishes and pour a little bit fixation into it. It's good to work on some dark, because you see the gonads better if you have black paper or anything.
Okay.
And in this case of the tiny spider, you have actually the whole spider here, because I wasn't able to to dissect it. So I will just simply take it and put it into the fixation.
Moving the specimen that's been the hypotonic into the fixation. Okay.
Yeah. The principle of fixation is to kill the cells and to dehydrate the cells. Yeah. So what we need to do is to gradually change the fixation. In this case, this was the complete spider, and I transfer it with a lot of drops of hypotonic solutions. So now it is already contaminated, which I don't want to, so I will put another fixation. I will just transfer the sample.
Okay.
I usually use the first fixation just to wash it from the hypotonic
Okay.
solution.
Okay.
Wash the tweezers and wash the sample itself. And here I will take leave it for some 10 minutes or
10 minutes.
Something like that. This is the case of when I'm working with abdomens or whole spiders. In case of gonads,
Just gonads only.
it's 10 minutes in first fixative and 20 minutes in second fixative. Now, always can be longer. You can never over fixate it, and I suggest to do at least 3 fixation.
Okay.
Let's say 20 minutes, 10 minutes, 20 minutes, and then put it into the fresh fixative for the last step for the preparation.
Okay.
Now, two pieces of appropriate size.
Okay, we're moving out of fixation to chromosomal prep.
Yeah. So here is the last piece of Hypochilus Petrukienvici.
Nice.
In this case, I will use. It's always you always need to try it. The optimal size. I think in this case of this size, gonads of this size, I think that from each gonad can be between 3 and 4 slides. So,
Okay.
So in total, some 6 or 8 from the whole spider of this size. Yeah, but you always need better always check under the phase contrast if the density of cell is too big.
Okay.
You are risking overlaps. If there is a few cells, you can just put bigger piece.
Right. Okay.
So always better to check it under the phase contrast. Or to be honest, I don't check it, but quite often I just put some piece of some size. Now this is, let's say, very minimum size, but haplogynes are usually full of cells. Their gonads are really full of cells. So this is. It depends. In jumping spiders, I usually take 1 gonad per 1 slide. They are usually poor in cells, not so dividing. This, I think, will be for at least 6 preparations.
Okay.
So here is the tissue of appropriate size, piece of tissue of appropriate size. We will take the cream.
That's a hypochilus gonad?
Yeah, this is the hypochilus gonad.
Nice.
The last quarter of hypochilus gonad, or maybe last fifth of fifth or 5 preparation from the hypochilus. Yeah, so we take the chromosomal cream microscopic slide. We always use this mark. Says superfrost.
Superfrost.
Superfrost is the special surface of the slide. It has higher adherency to biological material. This superfrost means that they made these slides under some special temperature. Oh, I don't know the procedure.
Okay.
But it should have higher adherence. There are even also possible to use superfrost plus, but they are too much. This is optimal. I always put the slides into the pure tunnel, at least for half hour, to
Okay.
to clean it. Just 90% ethanol. I reuse this ethanol. In fact, it is like that. The best ethanol for cleaning the slide is that one which was used for the slides previous. This is very important thing is the is the Jiří's t-shirt. And if you clean your slides with anything else than with Jiří t-shirts, you will get no chromosomes. so you just when you put it from the ethanol, you just clean it very well. Always check under the slide. For slide preparation of chromosomal slide, you need to prepare everything like this because this has to be fast process. So here we have a small piece of gonad. We can cut the gonad before it to have it prepared. Here we have 60% acetic acid, pasteur tip, which I use only for acetic acid, and pair of tweezers, microscopic slide, and this thing, which are needles in the glass. Actually, this needle is made from wolfram. We can let you some. We have this short, and this will allows us to make the suspension. So simply what I gonna do now is that I will transfer the piece of gonad onto the microscopic slide with the tweezers. I will drop it with a few drops, let's say 3 or 4 drops of acetic acid, and then I will squash it with those needles to make a suspension.
Okay.
Actually, usually it works like that. The acetic acid itself makes the suspension of the gonads, but it's always better to wash it to prevent cells be glued together.
Okay.
But in some individuals can be quite challenging to make a suspension, especially, or I mean, if you are working with females with ovaries, they are very hard to suspend, and some haplogens also you need to be very aggressive to make at least some cell suspension. Okay, so now I'm gonna try to work very fast because this piece of gonad shouldn't get dry. Yeah. So I'm gonna prepare the acetic acid into the pasteur tube. Here. I'll take both tweezers. One I use for transferring the gonad, and second is to keep it safe if there will be any problems. In the case that still here is the piece of fixative fluid, this is optimal situation. But when it gets dry, you need immediately put, for example, drops like this. And now I will make the suspension.
So the tissue is just kind of disintegrating now.
Yeah. This is disintegrated for each cell, each nuclei should be separate. You better be very aggressive during this step till the acetic acid isn't dropping everywhere around. You are doing it wrong. you need to be very aggressive. I usually do it like this, but maybe for the first time it's good to check it under the stereo microscope. You actually see the gonad.
Okay.
And now I immediately transfer it into the hot plate with 40 degrees, unfortunately, of Celsius. I don't know how much is it. And start to drag it. Initially the drop is pretty big, so I start to drag it with this glass part. But later when it gets smaller, I'm gonna drag it like this, only with the needle. I don't know, it is still too big, so let's say first 2 or 3 minutes I'm gonna move it with this glass part of the stick, but later I will use this part. It should work like that the cells gonna adhere to the slide on this part of the drop. So when you are moving, like now is the moment when when the cells adhere, or when the nuclei adhere. This should be done pretty slowly, like in this manner. Simply the drop shouldn't stay a long time. If the drop will stay like this for a long time, then the cells will adhere here around this, and you will have a lot of cells in these areas, and a lot of stain it. To stain it second day after not the first day.
Okay.
Slides like this you can store in the fridge, or store them in the fridge. If you want to use them for some fancy application, like for instance in situ hybridization, it's better to store them in the freezer. But before you put them in the freezer, you need to dehydrate them. You know, if you want to do this, ask me for protocol.
Okay.
You just put 70% ethanol, 80% ethanol, 96% ethanol, then let the slides dry, because when you put them into the freezer, there will be small molecules of water. They will produce crystals, chromosomes will be destroyed. This is how, but for some common fish techniques with these repetitive probes, for example rDNA probe, now the finalization.
Final drop.
Is that enough?
Yeah. And the slide is ready, and we just label it. And
How did you know you were done?